me get out of this. So, all right. So what are we doing today? What is this use case besides me yapping? Ansys scripting. Ansys scripting is basically a way of saying Ansys programming. We're going to make a program or two programs that are going to work with our output for a model. So this will be the assignment. We're going to have the results, and you're going to have to pull an image of the von Mises stress in that result, and also get data related to the stress values on the nodes and find that max value. And you're going to do this without using the GUI, just using two macros, which will be provided to you, and slight tweaks to get these things. So, do you want me to start on Workbench?
Sure.
Okay.
Go ahead.
I'll do that. So what I'm going to be showing is a little bit in Workbench, and then showing how you can move from Workbench to what I would call Ansys Classic or APDL, which is the more antiquated looking thing I mentioned. Sure. Starting mechanical. All right. So here's my very, very, very well modeled plane wing. As you can clearly see, this was made in Design Modeler. I generally do not use Design Modeler for CAD, but Design Modeler is used for partitioning, for slicing faces, which is relevant to meshing if you ever get into it. So what do we got going on in here? What's set up? I have the geometry in here. We got the part. The materials are set. A lot of the stuff you guys have already seen. Here's the mesh. That's where it's connecting. If I come down here, I've got a fixed support at the bottom of that guy, a fixed support over there, and I have a force acting down on it. So relatively simple model, relatively simple boundary conditions, simple force acting on it, nothing too complex. Don't want to do anything crazy there for what we're doing today. So you can look at this in Workbench as it is. You can solve this, you can look at the result. What we're going to do is show how you can get it over to APDL and then use it. So if I am in environment and I'm in static structural, I come over here, I have write input file, which I am going to open this up, and I'm not going to save this because I already have it saved and I won't write over it, but you can put whatever you need, whatever name you want in there. I believe you'll get the file, the APDL file as well, so you won't have to do this step, or are we doing this step too for Frozar?
Yeah.
Okay.
I'll give you the top.
All right. So I can save it as a .dat file, and I would just output this here. This is the start of what we're going to be doing, going from Workbench back in time. So I'm going to close out of this. This. Oh. All right, and I'm going to go to APDL and go to APDL Launcher, and I am going to put this as downloads CDS1 and run this. Yep. plot. All right. Okay. Now that looks less fancy than where we just were. So this is Ansys APDL, or Ansys Classic as it is sometimes called. I have separated the commands window over here. The command window, because that is how you predominantly interact with this software, is via commands. If I close this out, it goes back to its default place right here. If I click that, it pops back out. I'm going to keep it over here so you can kind of see what's happening as we're going through this. I'm going to go into the preprocessor. This is basically like where we were in Workbench. This is your area where you can bring in your geometry, you can do your meshing, apply boundary conditions, do loads. But I'm not going to do that because we already have an input for it. So I'm going to read input. I'm going to come down here, and I'm going to, is it that? No, not that. There we go. Presentation, APDL input file, ... And I'm going to hit OK. And that is all right. We're going to go past that. And it moved very quickly. So I'm going to come here. And, oh, well, nothing happened. Well, here's our first command. I'm going to do an eplot. And voila, I can now see my part. I'm going to click on this. You do use it to move stuff around, to look from different perspectives at your GUI. And look at that. It's my part. It's there. Wonderful. Happy. It got in. The mesh looks good. You can do a lot of stuff. So the pressure thing you see in the top left is keying you into that where that force is because it's acting on an area. So all good. We got it in, and now we can work with it in here. So we are going to solve this, which is going to be going to solution. This is where you run stuff. And I'm going to hit solve. And we're going to say, yes, that's okay. And that is all right. And it's going to go. And look at that. Our solution is done. Voila. It was a simple part. Normally that takes a lot longer. Now I'm going to go into the post processor. So I am here. And I'm going to go for set. It should all be in here anyways. But I'm now going to come into here. So I'm in post processor. I've got my plot results. Well, what does this thing look like? Let's go to contour plot and nodal results, stress, and von Mises. Look at that. It's right there. I can see everything. Wonderful. It's all there. So why would I want to do anything with this from here? Well, I'm going to show you two macros and explain why this might be useful to you to have these macros. I'm also going to just double check. Yes, I'm in the downloads working directory. Macros I can run from this command window over here. Macros are anything where it's essentially a file with .mac on it. And I'm going to first open them up and kind of talk about what they're doing, and then we're going to pop back in here and run them. You can see why they might be useful. I have, I'm going to save this because we're going to use that. Notepad. All right. So in the interest of time, I'll go through this semi-quickly. This is fully commented. You guys are going to get these. You can read these. These two commands right here are selecting your elements and your nodes. There's some information here about what you're going to be doing and reselecting your nodes. This right here is going to set your output. So it's going to take something we're going to do next and send it to a text file called result-output. And now we get to what we're actually going to do, PRN solve. So what is this kind of random bunch of words? This is going to print your stress, and particularly PRIN is your principal stresses. So now I'm not able to look at something in a GUI, in a where I can't do anything with it necessarily, I am going to print out all of the data and save it to a file. So I have that macro name. I'm going to come over here, on that. No data available for the selected model. Oh, well. I don't know. Maybe I should have looked at it before. But I think we should be good. Let's see what we did. Didn't actually. Interesting. I might have to diagnose that later. So normally I would expect there to be a whole list of nodes and stresses in there from that, but let's see why. Little sunlight. Yeah, we got one step. We got our first set. We got our point here. All right. Well, I'll play with that later. Like I said, normally it is printing the file, but for some reason it is not finding all of our nice data, which if I go in, we can see what it should do. And here you get to see a fun diagnosing line. But if you open All right. Well, I'll work with you a lot later. It should be pulling that out direct from that, so I'll play with that one.
How much of your job is spent trying not to throw things in there?
Too much. Here. Fun. All right. Well, I'll play with that one later for you. Might just end up being one. So that's one, which normally would work very easily, but here we are. Such is life. The second macro, also useful. All right. So this is doing something similar. We have selecting elements and nodes at the beginning, another command, which will just check here, see if this wants to behave. And I can take these, and these are just normal stuff that operates. And this is opening essentially this. And I'm going to do a REP just to refresh the screen. But this is what it should be bringing up. The S is again stress, and the EQV is equivalent, which is what they generally refer to von Mises as in this. So let's see if this one behave. Ooh. All right. And after it brings up that plot, down here I have image save, stress plot Jacob. So it's taking a picture. So the reason I did these, the two most common things you do is pull data out and pull pictures out. So having the ability to automate those are the two core things that go into analysis reports. That was the idea behind these. Best laid plans, as they say. And if I go in here, look. I have my stress plot. And you can configure this in more advanced ways where you can automate moving around to different views. So if I want to go through the trouble, I can make it so that it will go and take a picture of every angle I want, every element I want, print those out. If you want to get really fancy with those of you that know LaTeX, you can then have that automatically come into your report and update it. The other thing, everything that's been going on that I've been doing, you might say, well, this is nice, but this is great if I know the commands. I have to go and figure them out. But what if I'm just exploring this and clicking on stuff and then I do something I like, but I don't know how the command worked to do it? because you can click around. You can obviously go through all of these menus. So what do you do? Excuse me. What do you do if you end up in something like that and you want to see what you did? If I come here, I have, what is the most recent one here? 258. I believe it's 306. Stress plot. I think it will be this one. Interesting. All right. So this is a log file. Whenever you're opening up APDL, it will create a log file. And as you're doing stuff, including moving around the graphical user interface, as you're clicking through menus and executing commands, it's recording that. It's showing what you've done. So if you ever get to a place where you did something that you liked, but then you're like, oh, but I don't want to do this other thing I did. Well, I can come over here. I can take my log file. I can change my log at the end to a .mac. I can go and find the command that did something I didn't want to do. For instance, oh, well, I ran ru macro 2 here. Well, I didn't want to do that, so I'll remove that and go on and do something else. I only want to do rumac 1 because rumac 2 embarrassed me. So I can go in and remove that and make a new macro that is just that from what I did. So there's always a record of what it is. It's very useful. It's a great way to go and explore and figure out what commands are. And if you want to go from there and learn more about them, again, there's a link in both macros to a website. They link to different commands, but that website has basically every command listed on it. There are hundreds. I don't know 100 myself, but whatever you need to do, it probably is there somewhere, and it's a great place to learn and to see what is possible with it. This is just a teaser, just a taste. The capabilities of this are really just how much time you want to spend automating something or making a script for it or figuring something out. So that is my brief thing of Ansys scripting. Half successful. So thank you very much. And if you have any questions,